all, let's start with the next topic, gravitational potential. So, the gravitational potential is defined as the amount of work done in bringing a body of unit mass from infinity toward that point without acceleration. So, we have a unit mass at infinity. With at infinity, distance between them is infinity. So, we need to bring this unit mass closer to the source. So how would we bring? And that is actually known as gravitational potential. The work done in bringing this mass, small mass, to the source. So that is actually gravitational potential. Now we need to find out what will be the gravitational potential for this general equation. So I would be writing V as minus W over M. It is negative because we need to bring a mass m from infinity to a particular point. Let it be p here. So it will be v equal to minus w over m, and you know that w can be written as f dot displacement. So in this case, I will be writing as dr, and here we have m. Now the next thing is we can write f over m as I. So it will be I dr. Now I can be written as minus del V over del R. So that means we have a negative gradient of potential which gives intensity of field, or potential here is a scalar function of position whose space derivative gives intensity, and negative sign indicates that the direction of intensity is in the direction where the potential decreases, as we know, in this direction. Now, we need to know some important points of gravitational potential, and we need to study about some of the properties of gravitational potential. So the first is that it is a scalar quantity, not a vector quantity. As in the case of gravitational field intensity, this is a scalar quantity, and how we measure it is in Joule over kg, or you can write it as meter square over second square, and its dimension will be m0 L2 t minus 2. And if the field is produced by a point mass, then V will be equal to minus I dr, and I you know can be written as Gm over r square minus Gm over r square over dr. Now when I differentiate this value as infinity and r, it will be minus Gm r and over bracket r and infinity, and it can be written as minus Gm, r will be same, that is 1 by r minus 1 by infinity, that means minus Gm over r. So that means the work done is the measure of gravitational potential here, because the gravitational potential is minus Gm over r. So you can write that V is equal to W, that is equal to minus Gm over r. So let us consider some special cases here. So if I say that r is equal to 0, so if I say that r is equal to 0, that means v is equal to 0. And if I say that r is actually at infinity, then Vp will be 0. Hence gravitational potential is maximum, that is 0 at infinity. Now when it is at the surface of the earth, when r is equal to the radius of the earth, so it will be Vp equal to minus G M, and R is Re, because it is radius of the earth. We need to consider the gravitational potential between the center and on the surface of the earth. So it will be Re here. Now the next very important thing, that is point of zero potential. How to find point of zero potential between two objects. So let us consider that we have two masses, one is m1 and another is m, and we have space between them, and I would be considering a point here, that is P, that P is the point of zero potential, that P is the point of zero potential. Now the difference between them will be, let it be x between m1 and P, and the whole distance let us consider is d. So that means this distance will be d minus x, and this is my object A and this is my object B. Now my net potential will be, as you know that potential is added because it is a scalar quantity, so it will be VA plus VB equal to 0. Now in this case my VA will be minus GM1 over X, and my VB will be, with respect to P, is GM2 over D minus X equal to 0. Now I will be equating these values to get X value here. This will be a negative sign. X GM2 D minus X. G and G will get cancelled out, and I need to find X value. So I will be using cross multiplication here. Minus M D minus X equal M2X, and this will be my M1. And as you know that we need to find X, so I will be taking M1D. I will be expanding the left hand side, minus M1D, and would be taking M1X on the right hand side. So my X would be M1D, and I need to dilute that negative sign, so I would be writing it as M1 minus M. So this is the X value when the potential should be 0 at any given instant, or you can say in this case it will be at point P. So that's the end of this video. We'll continue with its escape velocity in the next chapter.